discriminant in the quadratic formula. So I have below here the quadratic formula, and we're going to focus on this piece right here. This is called the discriminant. And that discriminant tells us a lot about our graph, and if we will have real zeros or non-real zeros, we'll have x-intercepts or not x-intercepts, and how many we might have. So we're going to focus on b squared minus 4ac. Again, this is called the discriminant from the quadratic formula. We're going to focus just on this piece. So here's a little chart for you. If you have a positive discriminant, so number greater than 0, you're going to have 2 real solutions and 2 x-intercepts. If your discriminant equals 0, then you're going to have 1 real solution and 1 x-intercept. And if you have a negative discriminant, so something less than 0, you will not have any real solutions. You'll have what we call imaginary solutions, those things with the letter I, and you will have no x-intercepts. So here's what they're going to look like on your graph. You don't need to write these graphs down. So the first one, 2 real solutions. You'll have a x-intercept there and there, something like that. If you have 1 real solution, that means your discriminant equals 0. You'll have 1 x-intercept. And if you have a discriminant, which is a negative, then you have a parabola either below or above the x-axis. All right, a little picture here again. I just pulled this from the textbook. The same kind of pictures, just all 3 of them together. You don't need to write this slide down. I just kind of want to warm up with this question A. Here is an equation. It's a quadratic equation. It's not in standard form. So the first step is to bring that 7 over. And then you put in your A, B, and C into the discriminant equation, just underneath that radical. And you're going to notice you're going to get 8. And 8 is greater than 0. So that means you have 2 solutions. We're going to go ahead, if you want to pause and look at example B or example C. The discriminant is 0. So that means you have 1 real solution. Discriminant is a negative. That means it's less than 0. So you have 2 non-real solutions, complex solutions. Let's go ahead and try these now together. Find the discriminant and identify how many solutions you have. And then we could then go out later and use the quadratic formula. We'll do that on the next slide, the next video. So we want to identify the A, B, and C. So this equation is already in standard form. So our A is 4, our B is -4, and our C is +7. Again, it must be in standard form for you to use your discriminant. If it's not in standard form, change it so that it is in standard form. So now I'll go ahead and just plug it into the discriminant. That's what's underneath the radical in your quadratic formula. So b squared, so -4 squared minus 4a and c. Now let's simplify that. -4 times -4, negative times a negative, is a +16 minus, and then -4 times negative, or +4 times 7 gives you -112. Now subtract it. 16 minus 112 is -96. So there is our answer, -96. That is your discriminant. Now, is that discriminant greater than 0, equal to 0, or less than 0? Our discriminant, -96, is less than 0. So what we have, if we look at this, our discriminant is less than 0, we have two complex solutions. Imaginary solutions. It's going to be a graph where it's either going to be above the x-axis or below the x-axis. So it's going to have two non-real solutions. Make sure you have that, and they're non-real solutions, which means you'll have 0 real solutions. Which then means you will not have any x-intercepts because our discriminant is less than 0. Last example, find the discriminant, identify how many solutions there are. So this is in standard form. So we get 2 for our A, 4 for our B, and 1 for our C. We'll go ahead and plug it into the discriminant equation. So 4 squared minus 4A C simplified. 4 times 4 is 16. Negative 4 times 2 times 1 is negative 8. 16 minus 8 is 8. So our discriminant is 8. Since our discriminant is greater than 0, that's this first one here, we're going to have two distinct real solutions. We're going to have two x-intercepts.